Intro to Trigonometry. Trigonometry is the study of the relationship between sides and angles of right triangles. So in trigonometry, we have three special names for the sides of the right triangle. The first one we already know, we learned in the last chapter, in the Pythagorean theorem chapter, and that is the hypotenuse. So the hypotenuse is the side across from the right angle. The next two sides are new to us. They are the opposite side and the adjacent side. So when labeling the sides of a right triangle, it all depends on where the relevant angle is. So that's the angle that we're dealing with. So in some cases, it's the only angle that's marked, whether it's with a number or a letter. But in some cases, we have two different angles marked, and we have to decide which one is the important one, which one is relevant. So when we label a right triangle, the hypotenuse is always the side that's across from the right angle or the square angle. So in the first triangle, we can find the hypotenuse by looking across from that right angle, and it's right there. So the hypotenuse is always the longest side. The next side that we look for when we're labeling a right triangle is the opposite side. So just like the hypotenuse is directly across from the right angle, the opposite side is directly across from the relevant angle, or the angle that we're going to be working with. So in this case, the relevant angle is the x. It's marked with an x. So the side directly across from that is the opposite side, and we can mark that in. Finally, we fill in the adjacent side. So obviously, it's the only side left. Adjacent means next to, and the adjacent side is the one that's next to or connected to our relevant angle that's not the hypotenuse. So if you look, two sides make up our angle x, the hypotenuse and the adjacent side. So if we remember that the opposite side is across from or opposite our relevant angle, and the adjacent side is adjacent or next to our relevant angle, we shouldn't have any trouble labeling these triangles. So I want you to pause the video and take a second and see if you can label the other two triangles and come back and see how you did. Okay, let's look at the second one. So we should always label our hypotenuse first. It's the side across from the right angle. So our hypotenuse would be right there. Then our opposite side. So our opposite side is across from that relevant angle marked with an X, and it would be right there. And the adjacent side. So the adjacent side is the one next to or connected to the relevant angle, which is right there. And the third triangle, so our hypotenuse again is across from the right angle. The opposite side is the one across from the X, the relevant angle, right there. And the adjacent side is the one that's connected to the given angle, which is right there. So it's really important that we master labeling the sides of the triangle, opposite, adjacent, and hypotenuse, because it's the basis for everything we're going to do in this chapter. For every problem we're going to solve in this chapter, your first step is to label the sides of your triangle. So what I want you to do is stop right here and find the worksheet that has you labeling the sides of a triangle and give it a try before you go any further. So hopefully you did okay with labeling the sides of a triangle. Like I said, it's a very important skill, so make sure you've gotten enough practice with that before you move on. So there are three different ratios used in trigonometry. So what a ratio is when we compare a fraction, something over something. So in trigonometry, we're comparing a ratio of sides, which we'll see in a second, to the angles of a right triangle. So we're using equations that compare angles to sides so we can find the relationship between those. So there are three ratios that we're going to be using in trigonometry. There are others, but we're only going to focus on these three. So the first one is the tangent ratio, which we abbreviate TAN, tan. The second one is the sine ratio, which we abbreviate SIN. The third is the cosine ratio, which we abbreviate COS or cos. So we're going to start by having a look at the tangent ratio. So the tangent ratio is a mathematical expression that compares the angle of a triangle to two of the sides of that same triangle. So we're going to talk a little bit later about what tan or tangent actually means. We'll just put a pin in that. But for right now, the only thing we need to understand is that tan of x, and that x is a placeholder for our angle. Remember, we were using x to talk about our relevant angle. Tan of x is equal to opposite over adjacent. So that's our ratio of sides. So opposite over adjacent, or opposite divided by adjacent. Okay? So in the first problem, we had to find the tangent ratio for the following triangle. We just need to know that tangent is opposite over adjacent and use that to write our ratio. So remember I said before that every problem we do in this chapter starts by labeling our triangle. So let's do that first. So we have to find the hypotenuse, which is across from the right angle, which is 8.6. My opposite side, which is across from the relevant angle, or the x, which is 5. And my adjacent side, which is next to my relevant angle, which is 7. So 8.6 is my hypotenuse, 5 is my opposite, and 7 is my adjacent. But since tangent is opposite over adjacent, and my opposite is 5, and my adjacent is 7, I know that tangent is 5 over 7. Okay, so take a second and try the second problem. So label your triangle and see if you can find the tangent ratio. Okay, so let's look at our triangle. So my hypotenuse is across from the right angle, which is 4.2. My opposite is across from the relevant angle. So this time it's noted as a number, 17 degrees, instead of a letter or a variable x, but it's still a relevant angle. So the opposite side is across from it, which is 1.2. And the adjacent side is the one next to it, which is 4. So if I want to write my tangent ratio, which is opposite over adjacent, it would be 1.2 over 4. So the second set of examples has us doing the opposite thing. So it's giving us the ratio, and it wants us to label the triangle. So in the first case, tan of A is 1 over 2. So again, the first thing we always do is label our triangle. So we have our hypotenuse, our opposite, and our adjacent. And since we know that tan is opposite over adjacent, I know that my opposite side has to be 1, and my adjacent side has to be 2. And that's all we have to do to label our triangle. So try the second one and see if you can label that triangle. Okay, so first we have to decide which sides are which. So we have our hypotenuse, our opposite, and our adjacent side. So again, since tan is opposite over adjacent, I know my opposite side must be 7, and my adjacent side must be 8. So as you can see from the second example, that knowing the tangent ratio doesn't tell us anything about the hypotenuse. It only tells me about the opposite and the adjacent. So that's why we have other trig ratios to help bring in those sides that we haven't been dealing with. So with tan, we do a ratio with the opposite and adjacent side. So with that pairing, depending on which pairing we want to deal with, which pair of sides, we pick different ratios. So the second set of ratios we're going to look at are the sine ratios. So sine is equal to opposite over hypotenuse. So where tan had a ratio comparing adjacent and opposite, sine is opposite and hypotenuse. But we solve the problems the same way. So we label our triangles, and then we know which side is the opposite, which side is the hypotenuse, and we go from there. So I want you to try these two problems. So the first one is writing that ratio, and the second one is labeling the triangle. We're going to do it almost exactly the same as we did the tangent problems, only now we're changing our ratio. So it's opposite over hypotenuse instead of opposite over adjacent. So take a minute, pause the video, try these two problems, and come back and see how you did. Okay, so let's look at the first one. So again, we should always label our triangle first. So we have our hypotenuse is the side 5, our opposite is the side 4, and our adjacent is the side 3. So then if we want to write our sine ratio, which is opposite over hypotenuse, it would be 4 over 5. On the other, where we have to label the triangle, we start by labeling our sides or naming our sides. So we have our hypotenuse, our opposite, and our adjacent. Since we know that sine is opposite over hypotenuse, I know that my opposite is 7 and my hypotenuse is 8. So far I've compared opposite and adjacent and opposite and hypotenuse. But what if I want to compare my adjacent and my hypotenuse? I haven't developed that skill yet, and that's why we have our third trig ratio, which is cosine of x. So cosine of x is adjacent over hypotenuse. So go ahead and try these two problems. It's the same steps as we saw with tangent and sine, and come back and see how you did. Okay, so again, we have to start by labeling our triangle. So in our first triangle, we have 4.2 as our hypotenuse, 1.3 is our opposite, and 4 is our adjacent. So we know that cosine is adjacent over hypotenuse, so our ratio would be 4 over 4.2. So given the following cos ratio, label the triangle. So if we know that cos is 1 over 2, we should be able to label at least two sides of this triangle. So we start by naming the sides. We have hypotenuse, opposite, and adjacent. And since cos is adjacent over hypotenuse, I know that my adjacent side is 1 and my hypotenuse is 2. So if we use those three trig ratios, we can compare any two sides. So whichever two sides we want to deal with, we pick the trig ratio that goes with it. So if we want to deal with opposite and hypotenuse, we pick sine. If we want to deal with opposite and adjacent, we pick tan. And if we want to deal with adjacent and hypotenuse, we pick cosine. And the really neat thing is, if you look, for example, at this last triangle in this set, so we have the hypotenuse, which is 2, and the adjacent, which is 1. If we wanted to know what our opposite was, we have all kinds of skills to find that. So we can use our Pythagorean theorem if we wanted to find the missing side of O. So we can find out all kinds of neat things about right triangles with these skills. So what I want you to do now is stop, take a break, pause the video, and go and try the worksheet that has you dealing with sine, cosine, and tangent and writing just the ratios. Okay, so the final thing we're going to see in this intro is how to use your calculator to put this information in. So for example, if I have the tan of 15, what does that mean? So tan is a mathematical operation the same as sine or cosine. So they're mathematical operations that are done to a number. In particular, they're done to an angle. So just like we can take the square root of a number, we can take the tan of a number or the sine of a number or the cosine. So far we've seen mostly tan of x or cos of x or sine of x, but that x is a placeholder for an angle. So in the problems we're seeing here, that angle is actually filled in. And we're applying a mathematical operation to that number. So first thing I want you to do is check to make sure your calculator is in degree mode. So most calculators have 3 modes: degrees, radians, and gradients. We work only in degrees. So somewhere on your screen, there's probably either a D, an R, or a G. May also be DEG for degree, RAD for radians, or GRAD for gradients. If you're not sure, let me know and I will come and have a look and help you figure that out. But it needs to be in degree mode. So to solve a problem like tan of 15 degrees, so again, tan is just a mathematical operation. So like the square root of 16 is 4, the tan of 15 degrees is some value. So every calculator is different, but there are in general 2 ways to figure out what the tan of 15 is. So depending on your calculator, one of these 2 ways might work. So the first method is to punch the tan button. So somewhere on your calculator you should have a button that says tan. Then punch in 15 to represent the 15 degrees. And then hit enter or equal, or maybe OK, depending on what you're using. So that's the first method, is we hit tan, 15, and then enter or equal. The other type of calculator wants you to punch the 15 first and then tan. And if your type of calculator wants you to put the number in, the 15, and then tan, then you don't have to press equal or enter. It should just work by pressing tan. So you might try both methods on your calculator and see which one gives you an answer. So you should be getting that the tan of 15 degrees, if you put it in your calculator, is 0.2679. Now whenever we take the tan, the sine, or the cosine of a number, usually we get a big long decimal. Not every time, but in most cases we get a big long decimal. For these cases, I want you to take 4 numbers after the decimal. So in this case, the 4 numbers after the decimal are 2, 6, 7, 9. Later on, at the end of the problem, you can round it and make it look pretty. But for these steps, when we're dealing with taking the tan, the sine, or cosine of an angle, I would like you to have 4 places after the decimal, just to make it nice and accurate. So once you figure out how to punch that in your calculator, whether it's the tan and then 15, or whether it's 15 tan, you should be able to come up with 2679. If you're not able, you may be doing the wrong method of the 2, or you may not be in degree mode. So then we're going to try problem 7 sine of 61 degrees. So all that means is 7 times the sine of 61 degrees. So you're going to go and find the sine of 61 degrees, which you should be doing the same way you found the tan of 15, only instead of pressing the tan button, instead of pressing the tan button, you're going to press the sine button. So you should know by now whether you had to press the sine first or whether you had to put 61 in first. So once you find the sine of 61, you just multiply it by 7. So take a second and try that one, and then come back and see how you did. Okay, so you should have found out that the sine of 61 degrees is 0.8746. Remember, 4 places after the decimal. And then we multiply it by 7. And in this case, I then rounded. So remember I said when you first take the sine, cosine, tangent of a number, 4 decimal places. At the very end of the problem, when you're all done, 2 decimal places is acceptable. So in this case, it would be 6.12. Okay, and then we're going to go the other way. So the problem we just saw, we were given an angle, and we had to go and convert that into a decimal. So perform the operations on it. In this case, when you see the problems down at the bottom, we're not given the angle. So in number 1, it says tan of A, and A is representing that angle, but it's giving us the solution. So in this, whether it's 3 over 4 or 7 over 8, so it's giving us the answer, and we have to go back and find the angle. So when you wish to find an angle using any trigonometric ratio or trigonometry ratio, we must use our calculator and press the following button. So it's either a second button or a shift button. And again, the way we put this in our calculator depends on your calculator. So if you put the number in first before, you're going to put the number in first again, and then press second tangent or second sine or second cosine. If you press tangent before, first, and then the number, well, you're going to press second tan, second cosine, second sine, then the number, and then enter. So the order is the same as it was in the previous problem, but we have to press the second button or the shift button before we press our tan, our cotan, or our cosine or our sine buttons. So for example, tan of A equals 3 over 4. So because we're working in our calculator, fractions are a little bit difficult to deal with. So all we do is we convert that fraction to a decimal by doing 3 divided by 4, which is 0.75. So in our calculator, we would press the second tan or the shift tan and 0.75, and it will give us back the angle. So it'll give us back 36.86. But because we're looking for an angle now, and usually we don't like to deal with big decimals with angles, we're fine if we round that up to 37 degrees. So if you're not sure about putting that in your calculator, if you struggle getting the 37 degrees, let me know and I'll come have a look and I will help you figure that out. So the neat thing is, if you look at the problem that was given, tan A equals 3 over 4, that looks just like the triangles that we were dealing with way back when we were dealing with tan. That is one of those trig ratios. So remember, tan is opposite over adjacent. So in this case, opposite would be 3, adjacent would be 4. So what we're doing is we're taking that ratio, tan of A equals 3 over 4, and we're solving for that angle A. So we're using the opposite and adjacent sides to help us find out what that angle is because we didn't know. Okay? So the second one, sine of A equals 7 over 8. So again, we convert that fraction into a decimal, 0.875. And in our calculator, we press that second function sign or that shift sign, and we get that angle A is 61 degrees. So the third one, tan of A equals 5 over 4. So 5 over 4 is 1.25. So we use that shift or second function tan, 1.25. And we get 51 degrees. The fourth one is already in a decimal for us. We don't have to convert it. So we just use that shift or second function sign. And we get that angle A is 15 degrees. Cos of 1/2. So 1/2 is the same as 0.5. And we use our shift or second button. And angle A is 60 degrees. And cos of 0.08. So again, that's already in the decimal. We don't have to convert it. We use that second or shift button, and we get that angle A is 85 degrees. So that's the end of our intro to trig. We have a lot more trig to deal with, and all of the things we talked about in this intro we're going to visit again later on in our lessons. This is just to get everybody started and getting everybody thinking in the right mindset. But nothing that you saw in this lesson, nothing you saw will be the last time you see it. Everything we'll see again in future lessons. So if you were a little bit confused and a little bit lost, don't panic. It's going to come back again. So finish up any worksheets you had for this lesson, and then you can move on to the next.